Since we used the last couple of videos to talk about the Pythagorean theorem, I felt that it was a logical follow-up to go ahead and bring up the distance formula. And instead of formally proving this like I did with the Pythagorean theorem, I'd like to just kind of unpack it here a little bit and see what's actually going on here. The idea of the distance formula is to find your distance, you take the square root of whatever this weird x2 minus x1 squared is, plus this y2 minus y1 squared. Now the assumption here is this is if you're given 2 points, x1, y1, and x2, y2. The idea is that there's a point 1 and a point 2. And I apologize for the focusing on the video there. It likes to fade out for some reason. But we have 2 points given, so let's just say we sketch 2 points for a moment. Let's say this is our x1, y1, and that this is our x2, y2. The idea is that we're trying to find the distance between them with this formula. This distance would be the length d. The reason the distance formula works the way it does is actually very much related to what I mentioned earlier about the Pythagorean theorem videos. If I broke this down into a right triangle with a horizontal piece and a vertical piece, well, we would actually see then that the side lengths of this triangle, this length here and this length here, kind of our A and our B for the right triangle, would actually be very, very familiar to this formula up here. To find the length of A, I would take the x values and subtract them. I would say take x2 and subtract x1 from it. That would be the length A. The height here, the b value, would be to take the higher point, the y2, and subtract the lower point from it, the y1. So we actually see that this side length here, A, and this side length here, B, are the x2 minus x1 and the y2 minus y1 that were up here originally. Now here, D is taking the role of what we usually call C in these triangles, if we think about the Pythagorean theorem. So in that case, right now, with the way I've labeled this, we would see that D squared equals A squared plus B squared from the Pythagorean theorem. But in this case, we said that A specifically is x squared minus, not x squared, I apologize, x2 minus x1, and B is y2 minus y1. That should look very familiar now, and in fact, if you watched the previous videos on the Pythagorean theorem by any chance, you would take the square root of both sides typically to find that other thing, and now we see that distance formula. I guess really in a way this sort of is a proof. If you've accepted the Pythagorean theorem, then this did really just prove the distance formula works. So there you are. It's really just a matter of taking A and B and replacing them with the distances, knowing that to find the distance between 2 points, you just subtract them.